So we are at the Blaiken mine in the north of Sweden, not very far from the Norwegian border. We are in an area that is used for forestry, for reindeer herding. This mine is closed. It was in operation for a short while, 2006-2007. The mine went into bankruptcy and rehabilitation works has just started now, many years later. It was a zinc mine with some gold reserves. We are looking down at the open pit. It's a shallow, narrow, but very long open pit that was opened in a short while. The open pit is being filled with some sealing material, some lime and waste rock. Some of the open pits will be completely water-filled and some not. Here the waste rock dump we are now, that is going to be covered with the sealed layers. And the rehabilitation works will be ongoing for many years from now. There's a system in place now of cut-off drains that cut off the water running to the mine site, and there's also collection drains that collect the water coming from waste rock piles from open pits. And the collection drains lead to ponds where water is clarified and then after that treated and released into the environment. There's a larger lake and water reservoir below us. The water from the mine, the runoff from the mine will end up in that lake, and measures are now taken to capture the water, the surface runoff, and to clean that water before it is released into the lake below us. Here at the Blaiken mine, we have two main rock types. This black schist that was hosting the zinc mineralization. The black schist contains a lot of sulfide minerals, and they tend to weather quite easily, and they produce acid and metal-bearing waters. A lot of the rehabilitation works here at Blaiken concerns isolating the black schist from water and air, so the acid production is reduced. On the other hand, we also have the light-colored rocks on this side, which are mostly a tonalite, a light-colored intrusive rock that has much less sulfides, and it does not tend to produce acid waters. And this material we use to backfill and to cover other materials with. To distinguish these here is quite easy. With a hammer and your eyes and a hand lens, you can easily see and identify the more problematic rocks and the other rocks that we have here at Blaiken. So useful tools are your hammer and a good pair of eyes. At Blaiken, the black schist, which is the rock that hosts the mineralization, it will weather and disintegrate over time. The sulfide minerals in the rock, they will weather out. And with time, the black schist turns into this, a almost completely disintegrated rock where what is left of sulfides are iron hydroxides, and what is not here now are metals in solution in water. So the rock goes from the black schist in the ground that is exposed to water and air. It will over time disintegrate, weather. The sulfide minerals will weather and produce iron hydroxides and metal-bearing water. Here the weathering has gone quite far, and if left exposed for a long time, the entire rock mass will be weathered.
When you're starting a mine, you really need to know about your ore, but you also need to know about your waste rock and the tailings as well. And to know your waste rock, you need to make a comprehensive characterization. And characterization always should start that you have a sampling program where you have a representative sampling. In this way, you get to know your rock, and to get the representative sampling, you need to have some samples from the really coarse particle sizes, but also from the really finer particles. So you need to have a mix of these sizes. And you also need to know what places to take your samples in. So you can take the samples from a potential sulfide-rich area, such as in this place, but also in an area that is not expected to be that sulfide-rich, such as in these piles. So having a representative samples from waste rock is quite a challenge, because one rock could vary significantly from another one. So you need to take samples from different particle sizes and very large amount of samples.
We're at the foot of the waste rock dump. The tipping at the waste rock dump has created an angle that is slightly steep, and part of the rehabilitation works is to reduce the angle of the waste rock dump so that it will be more stable and easier to cover with sealing layers and soil for revegetation. Ideally, waste rock is covered with sealing layers and soil for revegetation as early as possible. If it is done progressively as the waste rock is being produced, the risk of acid rock production reduces the most. And the idea of progressive rehabilitation is a good one. Unfortunately, we don't see it at many sites at the moment due to the difficulties in planning both production and rehabilitation works. The water that falls on the waste rock dump somewhat will percolate through the dump and report to a collection drain at the bottom of the waste rock dump, and at that point water is collected and the water quality can be controlled.
Here, water has been transported via ditches surrounding the waste rock area, and is transported down here into the clarification pond where water is treated before it's let back into the environment.
Here at the mine, at the open pit that is currently being filled with rock, there are monitoring boreholes installed for monitoring the groundwater quality. In these boreholes we can measure the depth of water and also draw water samples to control the water quality over time, see how it changes. Here at the larger open pit at Blaiken, several works are ongoing at the same time. This main pit is now being water filled. There are pump stations and a network of water pipes to control the filling of the pit. The further pit wall is now being stabilized. The wall rock angle is reduced so that the wall is going to stand for a long time. A smaller pit further down is now being filled with rock and layers of lime to make that a rock-filled and limed seal. Excavators are working to make the pit wall safe and trucks are taking out the waste rock or the rock that is generating a lot of acid waters.
Here at the open pit in Blaiken, water is slowly filling out the pit because the water cover is quite an ordinary treatment method. Applying water above sulfides will hinder sulfide oxidation because oxygen is transported very slowly in water, which hinders the sulfide oxidation to proceed.
At this end of the large open pit, we have an excavator now removing the sulfide-rich and weathered rock from the bottom of the pit, and that rock is loaded and transported to the waste rock dump that later is going to be covered. The wall of the pit on the other side here is not very stable, and part of the rehabilitation works is to remove the very, very loose rock and then reduce the angle of the wall so that it can stand for a very long time without collapsing. When the loose weathered rock is removed, we are adding lime, and that in turn is covered with a clay-rich soil that is impermeable and reduces the transport of water to the sulfide-rich rock. The sealing layer is then turned with rock and soil, and eventually this section of the open pit will be completely filled up and the natural surface will be returned to how it was before mining. Back at the open pit again, the bottom of the pit floor has been cleaned, the very sulfide-rich material has been removed, and the pit floor has been covered with a layer of lime. And what we see here as the white is the lime, and the lime will increase the pH of waters in the pit. It will neutralize some of the acid waters coming from sulfide weathering. The lime is then covered with a clay-rich and impermeable soil that is compacted. That sealing layer is then covered with soil and rock all the way up to the top of the pit.
Here is the treatment pond, where water from the trenches and from the clarification ponds is transported to that building, where iron, hydroxides and lime is added to be able to precipitate the metals within this pond. The sludge is thereafter pumped from the bottom of the pond up to geotubes situated over there. The treated water is then released back into the lake. After being treated in the clarification pond, the lime sludge is pumped into these geotubes, where the lime sludge is dewatered, and then these geotubes is overfilled with an impermeable layer so that the water could not penetrate back into this geotube. The geotubes is underlaid by a hard layer so that the water could flow back into the clarification pond.
We are standing at the lake Storjuktan. So this is a lake and a water reservoir for hydropower. And the pipe here to my left is where water from the mine is finally discharged. So this is a discharge point for the water coming from the mine water treatment pond. So at this point, the water that is collected from the mine area and that is led to the different water ponds and finally the water treatment plant, it is discharged at this place. So this is where mine water meets the natural water outside of the mine area. The water at this point should have few metals in solution and it should be of good water quality, meeting the standards that are acceptable. So down here at the discharge point at Storjoktan, water is discharged from the water treatment pond. Water treatment is done at a cost, and the cost can be quite high. And of course, if the water delivered to the pond is of low quality, water treatment has to continue, which is an active water management function, and it is expensive. Ideally, water from the mine site can be released without costly and active water management, and rather water delivered to the lake of good quality without the need of water treatment. This is not yet the case here at Blaiken. So here down at the Storjoktan lake, the water from the mine is ending up. So previously we've seen the waste rock that is being covered. We have seen the open pit that is cleaned out and backfilled. Some portions of the open pit is being water-filled. We have seen a network of collection drains leading water to ponds where water is treated, and at this point water is finally discharged into the Storjoktan lake, a lake where people fish. And this lake then leads to one of the big rivers in Sweden. So all the efforts in rehabilitating the mine, cleaning water, should have a large effect and making sure that this water is of a standard acceptable to everyone.